Great. So in part 2 here, excuse me, I just want to wrap up with some multicollinearity things. And we'll look at a couple of examples. And again, multicollinearity, make sure to check the guide and see exactly how that works. But multicollinearity in general is just too much overlap between my explanatory variables in my model. And when there's too much overlap, R or any stat software doesn't know how to assign variation that's being explained by both variables. So if two variables move the same way, then they're going to explain a lot of the same variation in a response variable. And so R is not going to know where to assign that variation, and so it excludes it. And by excluding it, we see a big decrease in significance. And so variables that might be statistically significant on their own are no longer statistically significant as explanatory variables in a model. So now this doesn't violate any assumptions. It's not really a problem, only in that it does not help us identify individual factors. As I talk a little bit about in the guide, you can have a highly multicollinear model, and it can be still a really good model. There may be theoretical models that need certain variables. So even if there's multicollinearity, if theory says I need these three variables in my model, then that's what you would go with based on that theory. And sometimes we just want to have a really high R-squared and have as strong prediction power as possible. And so multicollinearity isn't really a concern at that point. But that's not going to be the focus in this class. But I just want to let you know that multicollinearity can very well exist in your model, and you could still have a perfectly fine model depending on what you want to do with it. So how can we check for multicollinearity? Well, it requires the car package. So install the car package, and then let's open the car package. I've already installed the car package, so I'm not going to do it here. So if we, excuse me, oh, for goodness sake, excuse the yawn, pardon me. Now, if we open the car package, that lets us use a command called VIF. And let's do one example here. Let's say I want to predict the number of games won using points per game and the number of assists that a team has. Assists is a basketball statistic. So if I run that model of points per game and assists, check the output. Not too bad, actually. Points per game is statistically significant, and assists is close, AST. It's technically not statistically significant, but there's a fuzzy room here. So if I thought having assists was important to me, I might still include it in this model. But anyway, let's actually assess, well, maybe there's multicollinearity that's causing my assists variable to be statistically insignificant. So all I need to do is run VIF and just put in the name of my model. And there we go. Let me make some space here. So in this case, I only have two variables. And so for mathematical reasons, they end up having the same, I only have two explanatory variables. So for mathematical reasons, they end up having the same VIF. And the VIF, is a quick reminder from the guide, is called the variance inflation factor. And it uses the R-squared from a regression of the explanatory variables against each other in a calculation. And that calculation, now you don't need to know this, but the calculation just says how much is the variance on a given explanatory variable going to increase because of multicollinearity, basically, in the model. So because of the overlap between points per game and assists, the variance on assists is going to be about 1.5 times higher than it should be if it were in on its own. And the points per game, theoretically, its variance is going to be 1.5 times larger than it should be if it were just in on its own due to this collinearity. But you don't need to know that deep of an interpretation. All I need you to see is that if the VIF is less than 5, then that's okay. That's good. Then there isn't a ton of overlap between our explanatory variables. And in this case, yeah, each one is under 5, 1.5 and 1.5. So I don't see any multicollinearity issues here. So I can... Oh, pardon me again. I am so sorry. Yawning all over the place. So I can sort of be rest assured that my assists variable is not statistically insignificant due to multicollinearity. So that's fine. But what about a case where there is a problem of multicollinearity? Well, let's go back a second to this interaction model that I ran up here of points per game, playoff, and points per game interacting with playoff. And I ran that as LM.3. And if we look at that summary again, I see massive statistical insignificance here. A 0.68 p-value on playoff and a 0.55 p-value on the interaction. That's huge. And the weird thing is, playoff is statistically insignificant here. But before the interaction, up here, when it was just these two explanatory variables, playoff was incredibly significant. So we might suspect that the reason playoff is now not statistically significant is because maybe of some multicollinearity. And we tend to expect this with interaction terms because an interaction term is made up of the other explanatory variables, so there very well may be some overlap. So let's check the VIF on this interaction model, LM.3. And sure enough, look at that. Points per game is fine. Its overlap with these other variables is not creating too much of a problem. But look at that. The playoff variable and the interaction term each have gigantic variance inflation factors. The variance on these terms is over 800 times what it should be because of collinearity, obviously between each other. So this is part of the reason why we don't see statistical significance. The other reason is that the other reason why we may not see statistical significance is that it's just not a useful term for us. But in any event, there's really nothing more we can do here. We get insignificant p-values, and we see high multicollinearity. So unless there's some really great theory or other kind of evidence that says we must keep the interaction term in our model, then we should get rid of it. And we would just get rid of the points per game and the playoff interaction. And that should help things. That just leaves us with our original indicator variable model up here. And everything, again, was statistically significant. So we'd probably expect that the VIF on this model, the multicollinearity is actually probably pretty low. And sure enough, it is. There's not a lot of overlap between points per game and playoffs, which is interesting. That seems sort of counterintuitive, but I can think of some sports reasons why that would be the case. In any event, everything makes sense here. I see a lot of statistical significance and no multicollinearity. And in the one area here where I see statistical insignificance, it very much is because of multicollinearity. And in contrast to this, in my original collinearity example between points per game and assists as explanatory variables, assists is not statistically significant. But when we look at the VIFs, it's probably not because of multicollinearity. The assists variable just might not be a useful variable for us in predicting the average number of games won. So VIF is a really powerful tool, and it lets us start to assess things we want to keep into our model or things we may not want to keep in our model. And it helps us go beyond just looking at the p-value. It gives us a little bit more information about what's happening. And again, it's a very efficient function because, yeah, we could go through and do correlations between different variables and try to figure out what a limit might be, 0.7, 0.8, for a correlation that becomes problematic. But the VIF is direct. It's one command. It gives us all the information, and we can make a pretty good decision from here about what to do with each model, at least at this point. So that's sort of how we tie this together here, the multicollinearity and some of this interaction model stuff. But from here going forward, I encourage you just for fun to do the VIF on any model you do, even if I don't ask you to do it, and that can help you assess what's going on. So it's a pretty cool tool, and I really like it. So that's it for this video, and that's it for videos this week. Make sure to check out all those guides. If you just go through them, you should have more than enough for getting through the activities, future homework information, exam, that kind of thing. So it's all there. And all right, well, I hope this was helpful, and thank you very much.